Good morning, everyone. We're here to talk to you today about our Android application called RoamGame. So my name is Vinu Diokar, and I'm an EC Master of Engineering student. And this is Justin, and he is an EC Master of Engineering student as well. Our specialist is an external specialist, Dr. Katzman, who is a professor of psychiatry at the University of Toronto, specializing in brain and therapeutics. He is also a psychiatrist at the START Clinic in downtown Toronto. So the motivation for our project revolves around a characteristic called the intolerance of uncertainty, or IU for short. A big part of Dr. Katzman's research revolves around this characteristic, which is an indicator of a mental health state, and has also been linked to other issues such as various forms of anxiety and depression. Just to explain the concept a little bit more, as you can see in the image behind me, we all face day-to-day uncertainties, such as if there's traffic on the road, if you didn't study enough for an exam. Someone with a high level of IU would actually find these uncertainties very intolerable and may experience symptoms such as stress, grief, or lack of sleep. And it's important to note that these are future uncertainties that might actually have a very low probability of occurring, but someone with a high level of IU would actually not be able to stand this intolerance, or not be able to stand this uncertainty. So the goal for our app, currently the IU data is collected via surveys. And this is obviously problematic because it relies on self-assessment. It's not very fun to take, and then it also does not capture any behavioral data. So our idea was to build an app to facilitate IU data collection and to really be used as a tool for psychiatrists. And the key idea here is that we build a game that has IU elements where user behavior can be monitored and collected. So just to give a high-level block diagram of our app, in this diagram, the white arrows denote logic flow, and the green arrows denote data flow. So in addition to our game module where we collect IU data from users, we also have a user profile page and IU survey data that is collected and stored in a local database.
Okay, so for this part of our presentation, we want to show our app and game in a way that we intended to be used by Dr. Katzman himself. So for this part, I'll be playing Dr. Katzman, administering the test to patients with varying IU levels, played by Vinu. Hello, Michael. I was wondering for today's session whether you could try a new game out. Sure. Could you first fill out some profile information so we have you? Okay. So just to give a brief description of how the game will work, the game is essentially an adventure game where the goal is to collect barrels to receive points, and you want to do this without losing health, which you can do by avoiding the following obstacles. And at the end of the game, you have to return back to an exit house where you can redeem your points. And there's also a health house where you can go to occasionally to regenerate your health back so that you can continue playing. So the way that the map is set up is that there are different zones. So in the inner zone, the hazards are less uncertain. So there's only Grim Reapers that can collide into you in this zone. But as you go outwards, there's more random elements of uncertainty that can pop up and cause you to lose health. And if you go even further out, there's even more. So, do you think you understand the game?
Yep.
Okay, so if you can just start playing right there. Okay, so while Michael is playing this game, I just want to inform you guys what the IU scores are at the top. So this is invisible to Michael right now, but essentially they're modeled after the IU survey. So there, you see there's two scores here, factor 1 and factor 2. Factor 1 is supposed to reflect how uncertainty creates negative behavior, and the factor 2 score is supposed to reflect essentially that uncertainty is unfair for the user. So this is just a formula that we created to kind of show the potential of how the user behavioral data can be used to diagnose IU. So this is just our example formula that's based on various factors. So you can see Michael is playing very timidly. That's why his IU scores are quite high. But if Michael became Robert, someone else, he's willing to take more risks, and he's venturing farther into the map where there's more hazards. And these hazards randomly spawn around him, creating a definitely more uncertain atmosphere for him. So you can see he's picking up barrels, and those barrels actually regain health. But in this region, it's very uncertain for him because he can get trapped in areas. So as you can see, compared with Michael, you can clearly see that his score is much lower. And if he's willing to take even more risks and go into this house, there's actually like a teleporting witch that can glide into him. But there's also a huge reward for going here, and you can see his IU score also going really low when he's picking up the health pack. So yeah, so at the end of the game, if he chooses to, he'll receive the final score, and those IU scores won't be visible to like the patient. That's just to demonstrate logging like the IU score that we created. Okay, so just to talk about the project, we thought the things that went well was the actual game development. So we didn't have that much experience to start with, but we essentially went through some tutorials and created a basic 2D game, and then we understood like the constraints and what we could accomplish. So that kind of allowed us to build on that and achieve our goals. And some things we wanted to improve on was early on we felt that we should have brainstormed more in terms of the IU elements. And the one constraint was like we weren't able to meet with our specialists very much, but we still felt that we could have made a sandbox version of our game and test out various things before actually implementing like the graphics and everything. So yeah, next time we would have done it that way.
And for the future work for our app, some things we could do to improve are to make a better interface for viewing the data for psychiatrists and Dr. Katzman. We could also get more data collection from the user through various sensors like accelerometer, gyro, or heart rate monitor. And another thing we could do is add more IU elements or make the game more immersive, so maybe better graphics, maybe add some vibration, sound to play on other mental aspects of users. And then the future aspiration for our app is maybe one day to be used as a tool by psychiatrists worldwide to collect IU data. Thanks.
That's really interesting. Just intolerance of uncertainty would go up if you didn't go venturing, but that number looked like it was going up when you were venturing, but it's actually tolerance of uncertainty. Right?
So yeah,
scoring.
So essentially there's two scores and
no. My question is about the score itself.
Yeah.
It should be called the tolerance, not intolerance. Is that right?
It's actually intolerance. So the higher the score would reflect more like higher IU.
Yeah. So when we go further away, like there's a slash. So basically, it's like there's it's out of the max score. So like when I venture further away, that the first part of the score, like before the slash, actually decreases. So it starts out with a max. Like if we start the game and you're just standing in the interior region, it's gonna be a max score. And the further you go out, and like that's the factor one, and then the other one is like how much you're moving around, then the scores will decrease over time. But the thing is, it's cumulative. Like the way we did it was per frame. So like it takes a while before the score starts to drop. And then there's also a minimum score. So the survey is like from 1 to 5 or 1 to 5. So there's no 0. So the actual like min score of for the 75 score, I think it's like 15 or something like that, or 20, something like that. So like it doesn't actually go below that mark.
So the other thing I want to point out was like one of the scores is actually based on speed. So if he momentarily stops, it's going to shoot up. But it's based on the willingness to move. So that's why real time is going up.
And you invented those factors just from your own thinking, without much guidance.
So from the IU survey, there's like a bifactorial like assessment where you can add up. I think Dan probably knows. You can add up the scores in 2 categories. So we modeled it after that. So like there's a definition for each category, for each factor, and then we kind of like based on our game elements, we kind of tried to match those elements into the factors, and then like summed it over the range of values.
And I'd like to add that like the main purpose of our app is to kind of get the user behavior data out. So that was just to demonstrate the future potential. Like Dr. Katzman himself can decide how to use that data. It might not be our formula, but
sure. Yeah, absolutely. Any other comments or questions? Yeah.
Just a comment. I think it would be very interesting if you can add like a photo or effect, and as you like go like further away from like the city, like the vision basically becomes like smaller and smaller. So then like I think that would be a good addition.
yeah, that's interesting.
Do you think playing the game multiple times will create some learning effect that will underestimate IU?
So this is actually one of the things we hope to accomplish, right? So like users by playing the game, they might be more encouraged to take risks. I think that's. But in terms of an assessment, I think maybe Dr. Katzman might just let users play once just to assess them, and then after like they can probably play more times, and then like obviously every time they play, they'll be willing to take more risk, right? So, or they should be potentially.
We can try to trend this.
Great.
Yeah.
Well done.